Assalamualaikum warahmatullahi wabarakatuh. Hello guys, how are you today? I hope all of you is good. Okay, let me introduce myself. My name is Akbar Rafli from 6A class at Islamic State University Sultan Syarif Kasim Riau. Okay, so today I will tell you about my presentation. The title is Conducting Statistical Tests and Calculating Effect Size. Okay, let's start it. For the first is selecting the appropriate statistical test regardless of the actual statistical test concerned. Each one tends to follow the same logic. The first, each statistical test involves a calculation that produces what is known as a test statistic. This test statistic summarizes in one number the nature and size of relationship between the two variables concerned. Second, the test statistic is either already standardized or can be standardized once we know what are called the degrees of freedom for the statistic. The third, with each test statistic and its associated degrees of freedom were relevant. The statistical test is then used to calculate the probability of the finding concerned having occurred by chance, assuming that no relationship actually exists between the two variables in reality. The fourth, it is it is this last bit of information, the statistical significance of the finding, that is important. And the last is finally alongside reporting that is finding statistical significance. It was stressed in the last chapter that is also important to provide some sense of the actual substantive importance of the finding. It is for this reason that we also tend to calculate and report the associated effect size. Okay, G-square test. The first example we will use to illustrate the G-square test is the one discussed in the previous chapter concerning the relationship between a pupil sex and their likelihood of being bullied. As explained in the last chapter, the first step is to derive the hypothesis or the alternative hypothesis HI we wish to test, and the second related step is to state our corresponding null hypothesis or HO. In this case, the hypotheses are first, HI, there is a difference between male and female students in terms of their likelihood of reporting being bullied. The second, HO, there is no difference between male and female students in terms of their likelihood of reporting being bullied in school. Okay, to open this, you have to open the bullying SAV dataset and then select Analyze, then Descriptive Statistic, and then Crosstab. Okay, the next is Mann-Whitney U-test. To demonstrate this statistical test, we will return to the example covered in chapter 3 that consider the relationship between a child's sex and the overall school grades their parents reported that they were achieving in America. Our first step, as usual, is to specify the alternative hypothesis we wish to test and then to state the associate null hypothesis. In this case, these are first is there are difference between boys and girls in America in relation. to the school grades they achieve. The second, how there are no differences between boys and girls in America in relation to the school grades they achieve. Okay, to do this, you have to select Analyze, Non-Parametric Test, and then two independent samples, and then this open the two independent samples. The next is Kruskal-Wallis test. To demonstrate the Kruskal-Wallis test, we will stay with the after-school SAV dataset and the variable cigarettes. However, this time we will see whether there is a relationship between the racial or ethnic background of children and the school grade they achieve, as reported by their parents. Okay, the alternative and null hypothesis, this is time are HI, there are differences between children from differing racial or ethnic backgrounds in America in relation to the school grades they achieve. HO, there are no differences between children from different racial or ethnic background in America in relationship to the school grade they achieve. Okay, to do this, you have to test using analyze and then non-parametric test and then k independent samples. The next is independent sample test. For this next example, we will use the evaluated the SAV dataset, and for the purpose of illustrating this and the following statistical test, we will assume that the school in the dataset are samples have been randomly selected from the four local education authorities, or LEA. The hypothesis we will test and its associated null hypotheses are: the first, i.e., there is a difference between the city of Leeds and the city of York, LAA, in terms of the academic performance of pupils in their schools. Second, however, there is no difference between the city of Leeds and the city of York in terms of the academic performance of pupils in their school. The next is one-way ANOVA. To demonstrate the one-way ANOVA, we will stay with the evaluated .sav dataset and will continue to assume that the dataset represents samples of schools randomly selected from four LEAs. The alternative and null hypothesis can therefore be stated as follows. The first, i.e., there is difference between the four LEAs in terms of the academic performance of pupils in their schools. The second, there is no difference between the four lists in terms of academic performance of pupils in their school. To do this, we have to select Analyze, Compare Means, and then One-Way ANOVA. The next is Spearman and Pearson correlation. Conducting tests for statistical significance on correlation, whether Spearman or Pearson is actually the most straightforward procedure of all. Here we will expect to find a positive correlation, and so we can use a directional hypothesis. The first, i.e., there is a positive correlation between the ages of a young child mother and father in America. Second, however, there is no correlation between the ages of a young child mother and father in America. To do this, we can choose a scatter plot using the graphs and then the legacy dialects and then scatter or dot procedure or just graphs and then scatter or not. The next is Wilcoxon test. The first thing we will do here is to assess whether the children who attend the reading and drama club actually increase their liking of reading over the years or not. In this case, the alternative and null hypotheses are first i.e. the children's liking of reading was higher at the end of school year compared to the beginning. The second HO there was no difference between the children's liking of reading at the beginning and the end of the school year. Okay, before we run the test, we need to use the data and then select cases. Proceed to select only those in the reading and drama club, and once done you run the test by selecting analyze and then non-parametric test and then two related samples. This open the two related sample test. The next is related sample test. You're so golden. Alongside when wanting to assess whether the attitudes towards reading of the children attending the reading and drama club had improved, it was decided to assess whether their actual reading skills had improved as well. This time, therefore, the alternative and null hypotheses are for HE, children's reading skills were higher at the end of the school year compared to the beginning. The second HO, there was no difference between the children's reading skills at the beginning and the end of the school year. Before we run this test, however, we need to be sure that the following two conditions are met. The first, that we are dealing with a scale measure. The second, that the scale measure is normally distributed. To do this, select Analyze, compare means, and then select Paired Sample T-Test, and this open the Paired Sample T-Test. Okay, I think that's all about my explanation about conducting statistical tests and calculating effect size. I'm sorry if I have some mistakes. Last I say, Assalamualaikum warahmatullahi wabarakatuh.